Feeding relationships in marine ecosystems. Understanding the food web. Welcome to our presentation on feeding relationships in marine ecosystems. In this presentation, we will explore the intricate web of interactions that sustain life in our oceans. Introduction. Definition of marine ecosystem. Importance of feeding relationships. Marine ecosystems encompass all living organisms and their physical environments in the world's oceans, seas, and coastal areas. The focus of our presentation is on feeding relationships, which are essential for energy transfer and the balance of marine life. Understanding these relationships is crucial for preserving ocean health. Marine trophic levels. Primary producers, phytoplankton. Primary consumers, herbivores. Secondary consumers, carnivores. Marine trophic levels categorize organisms based on their feeding habits. Primary producers, such as phytoplankton, are autotrophic and form the foundation of marine food chains. Primary consumers are herbivores that feed on primary producers. Secondary consumers are carnivores that prey on primary consumers and other carnivores. Types of marine organisms. Planktonic organisms. Benthic organisms. Nectonic organisms. Marine organisms are classified based on their habitat and mobility. Planktonic organisms are drifters, including both phytoplankton and zooplankton. Benthic organisms reside on the ocean floor. Nectonic organisms are swimmers and can move independently in the water column. Food web concept. Interconnectedness of species. Energy flow in ecosystem. A food web represents the complex network of feeding relationships in an ecosystem. Species are interconnected because they often have multiple predators and prey. Energy flows through the food web, with energy transferred from lower trophic levels to higher ones. Keystone species. Definition and importance. Examples in marine ecosystems. Keystone species have a disproportionately large impact on their ecosystem relative to their abundance. Their presence or absence can significantly alter the structure and function of the ecosystem. Examples include sea otters, which control sea urchin populations in kelp forests, and coral, which builds reefs that support countless species. Trophic pyramids. Explanation of trophic levels. Pyramid of numbers and biomass. Trophic pyramids illustrate the distribution of energy and biomass in an ecosystem. They consist of different trophic levels, with primary producers at the base and top predators at the apex. Pyramid of numbers depicts the number of individuals at each trophic level, while the pyramid of biomass shows the total mass of organisms. Human impact on feeding relationships. Overfishing. Pollution. Climate change. Human activities have profound effects on marine ecosystems, disrupting feeding relationships. Overfishing depletes fish populations and affects food web dynamics. Pollution introduces toxins and disrupts food sources. Climate change alters ocean temperatures and acidity, impacting species distributions and behaviors. Conservation and management. Sustainable fishing practices. Marine protected areas. Research and education. Conservation efforts are crucial for preserving marine ecosystems. Sustainable fishing practices ensure the long-term health of fish populations. Marine protected areas, MPAs, safeguard critical habitats and biodiversity. Research and education play vital roles in understanding and protecting marine food webs. Conclusion. Recap of key points. Call to action for marine conservation. In summary, marine ecosystems are intricate webs of feeding relationships. Understanding these relationships is vital for conservation efforts. We must take action to protect and sustain the delicate balance of life in our oceans for future generations.